This is a lesson on parallelograms. So parallelograms are four-sided figures with opposite sides that are parallel. So look at the way that I show that. Here's my four-sided figure, and I'm showing with my little arrows that those sides are parallel to one another. That's the definition of a parallelogram. Now, in this unit, what I've generally found is that we find out that students are not being very precise with their language. So if I were to draw this shape, I'd have some students to tell me, oh, that's a square, or that's a rectangle. There are distinct differences in classification that require us to be very precise. I want you to think to biology. You should have already had biology, or maybe you're taking it this year. If I saw here a duck, so envision in your head what a duck looks like, and in here I have a pigeon. Imagine what a pigeon looks like. A child, a young child, not you, would say, that's a bird. And they'd say both of them are birds, right? But the more precise classification would be, yes, they're the same, kingdom, phylum, class, order, family, but at some point they split. And a duck is not the same as a pigeon. They have different features and properties. We classify them differently. The same thing is true in math when we talk about these different kinds of parallelograms or different kinds of quadrilaterals. So it's important that you pay attention to what causes me to differentiate between the two. I have to be able to define them carefully. So we're starting with the foundation. The foundation is opposite sides are parallel. It's a parallelogram. Boom. Okay? Now, because a figure is a parallelogram, it has certain properties that are true that we can use. Okay? If a figure is a parallelogram, it also has opposite sides that are congruent. So I'm going to mark that. This side must be congruent to this one, and this one must be congruent to this one. Notice they're not all four congruent, but the opposite sides are congruent to each other. Okay? Check. It has opposite angles that are congruent. Now, opposite in this figure doesn't mean here, it means here. This angle will be congruent to this angle, and this angle will be congruent to this angle. Opposite angles, congruent. It has consecutive angles that equal 180. Consecutive means next to each other. Remember our consecutive interior angles? So this angle plus this angle equals 180. This angle plus this angle equals 180. This angle plus this angle equals 180. And this angle plus this angle equals 180. Okay? It has diagonals that bisect each other. Well, I don't even have diagonals. Let me draw them in. Diagonal goes from corner to corner. Now, if they bisect each other, then I know that this one must be congruent to this one, and this one must be congruent to this one. They aren't congruent to each other. I only have these two pieces that are the same and these two pieces that are the same. So if you did not do that as I went through them, you need to make sure you draw that and make all of those marks in your notes. This will be true for every single parallelogram all the time. Now, all parallelograms have those properties, but some parallelograms have even more properties. So for instance, a rectangle is a parallelogram with all 90-degree angles. So that slanty parallelogram gets pushed straight up, and now it becomes a rectangle. A rhombus is a parallelogram whose all four sides are congruent. And a square is both a rectangle and a rhombus. It's a rectangle in that it has all four sides at 90 degrees, all four angles at 90 degrees, and it's a rhombus because all four of its sides are congruent. Okay? Now we'll talk more about those in a future lesson. I just wanted you to understand that these are special kinds of parallelograms, but I'm still going to be talking about in general all parallelograms today. Okay, so it might look like this, but it might not. So typically, how are you going to have to solve problems with this? You'll get a question like this. If ABCD is a parallelogram, here it is, what is the value of x? You're going to look at it and go, where's my x's? Okay, here's an x and here's an x. Well, they're on opposite sides, so now I have to remember my properties. Opposite sides are congruent. I'm going to write an equation that says 4x equals 6x minus 4. Okay? Negative 2x equals negative 4, x equals 2. So I look at the picture, I see what property applies to it, I write the equation and solve it. What is the value of y? Okay, y is here and y is here. I don't think those are congruent. Consecutive angles are supplementary. So I'm going to write an equation that says 2y plus 5 plus 3y equals 180. And now I have 2 y's and 3 y's, so I have 5y plus 5 equals 180. 5y equals 175, and so y equals 35. I did that kind of quickly. You have it written down. You can pause this and make sure you have that written properly in your notes. The important thing is I see where the y's are. I say, what's the relationship? Oh, it's supplementary. I write the equation that shows supplementary, and then I solve it. Okay? The next question says, what's the measure of each angle? Well, let's see. If I know what y is, I think I could plug that in. 3 times 35. 3 times 3 is 9. That's 105. So this angle is 105. Now, what do you know about angle B? Congruent. It's also 105. This one, so let's put 2 times 35 plus 5. 2 times 35 is 70. So this angle is 75. And what do you know about this side over here? It's also congruent to its opposite, so it's also 75. So if you know one angle in a parallelogram, you can subtract from 180 or move it around, and you can find every other angle in a parallelogram. Okay? And then what is the measure of each side? Well, let's see. We found out that x equals 2, so I'm going to plug in 2 right here. 4 times 2. This is 8, and I know this is 8. I have no idea what those other two sides are, and I can't figure it out. So all I know is that AB and DC both equal 8 because I found X. There's no information here. There's not enough information to know the other sides. This is the kind of problem that you will have to do with those properties. So in the beginning, when you're first starting this out, I would like to see you with your note sheet or your foldable or whatever you have where you are referring back to it over and over again. What are those properties again? How can I set up that equation? Okay, question type 2 would say, well, I'm not sure this is a parallelogram. What value of x or y would make this a parallelogram? So you're kind of doing the same thing, only it's a slightly different question. Now I just have a quadrilateral, and I want to prove it's a parallelogram with numbers. So I look at x's. I have 4x and 5x, but I don't know anything about these two, but these are diagonals. And I know that this must be congruent to this side, because diagonals of a parallelogram bisect each other. And this must be congruent to this. So I could write an equation. I could write 4x has to equal 28. So x equals 7. And double checking, I could say 5x has to equal 35. So that x also equals 7. So in this case, if x equals 7, this is a parallelogram because the diagonals bisect each other. Not just one of them, both of them bisect each other. Okay? Now, what about y? I'm going to look at the relationship for y. If this is a parallelogram, then this top part should be congruent to this second bottom part, right? So let's see. 10y equals 14y minus 20. Minus 14 is negative 4y equals negative 20. Y equals 5. So if y equals 5, the top and bottom are the same. But I got to check the other two sides too. So I'm going to plug in a 5 here, and I get 30. Let's plug in a 5 here. 8 times 5 is 40 minus 10, and I get 30. Opposite sides are congruent, so if y equals 5, then that's a parallelogram. Or if x equals 7, that's a parallelogram. Okay? If that wasn't kind of fast for you, you go back and you watch this again and think about it again. So what I'm looking for is, what was the relationship supposed to be? If this is a parallelogram, this is supposed to be equal to this. So that's what I wrote. If this is a parallelogram, this is supposed to be equal to this. So that's what I wrote. Okay, last thing we're going to do is use these properties in a proof. So situation number 1, I'm given ABCD is a parallelogram. Prove that triangle AED is congruent to triangle CEB. So I've highlighted them for myself because there's a lot of triangles inside this parallelogram. Lots of stuff going on. So I wanted to make sure I knew which ones they were talking about, so I highlighted them there. So the first thing I wrote down is my given, right? Because I will never have an empty paper. I'll always be able to write something down. Given. Now, what does that actually mean? So let's mark up this triangle. That means opposite sides are congruent, right? That means the diagonals bisect each other. And I guess this side would also be congruent, but it doesn't really matter for my problem because it's not in my triangle. So what I notice is that I have a side, and a side. So I'm thinking in my head for my plan, I'm going to use side, side, side. So I have to list those sides before I can say side, side, side. So I'm going to write DC is congruent to AB. And why is that so? Opposite sides of a parallelogram are congruent. Remember, they told me it was a parallelogram. And I'm using shorthand here. Opposite sides of a parallelogram are congruent. So now I have my first side. Yay! Now take a look here. CE is congruent to EA, and I'm going to put these two together in the same because they're the same idea. DE is congruent to EB. You know, marks on top. Both of those two reasons are the same reason. Diagonals of a parallelogram bisect each other. Remember, they're the ones who told me this was a parallelogram. So I don't have to prove it's a parallelogram. I'm just going to use what I know about parallelograms to try to find parts that I can use for these triangles. So now I notice I have S, S, S. So I'm done. Let's just draw this same thing right here and then write our reason, side, side, side. Okay? So the way that we're going to use this in a proof situation is we're going to take the fact that it's a parallelogram, mark up all the parts and pieces we might need. Like if I needed it, I could have marked this side and this side, right? If I needed that information. I could have used these vertical angles. I didn't need them, but I could have. So there's other things that I could have used, but the fact that it's a parallelogram gave me that information. Okay? Make sure you have the copy of this in your notes so that you can do it yourself.